Welcome to the series of videos where we solve the questions in the 2026 WASSCE Core Maths Paper 1. In this video, we solve questions 31 to 40. And as usual, the full set of questions and solutions can be obtained from our website, preppyonline.org. Question 31. In the diagram, line segment PQ equals line segment QR. That means that the length of PQ, which is from here to here, this is the same length as QR from here to here. And that's what this means. So that means that we have an isosceles triangle here. All right. Angle PQR is 50 degrees. That's this angle. And angle PRN is 4x minus 5 degrees. That's this one. Find the value of x. One way we can do this is to first see that because this triangle is isosceles, we have that this angle and this angle have the same measure. So if we call this y, that would mean that this is also y. So if we use the fact that the sum of the angles in a triangle is 180 degrees, then we have that y plus 50 or 50 degrees equals 180 degrees. So we have 2y, let me write that, 2y plus 50 degrees equals 180 degrees. That would mean that 2y is 180 degrees minus 50 degrees, that's 130 degrees. That means that y equals 65 degrees. So we have that this y is 65 and that y is also 65. Now, using the fact that y and 4x minus 5 are two angles on a straight line, we use the fact that the sum of the angles on a straight line is 180 to write that y plus 4x minus 5 is equal to 180. These are two angles on a straight line, so they must add up to 180. So we substitute y equals 65 into this. So we have 65 plus 4x minus 5 equals 180. So we have 65 minus 5. That gives us 60 plus 4x equals 180. So we subtract 60 from both sides. That gives us 4x equals 120. So if 4x is 120, we divide both sides by 4 to get x equals 30. So that gives our answer as B. Question 32. Given that 4x minus 2y equals 1 and 3x minus 4y equals minus 0.5, find the value of x plus y. So when we're asked to find the value of x plus y, normally we want to see if we can manipulate these two equations, or if we can find a way of adding or subtracting them in some way to immediately give us x plus y. But when we try to do that, for instance, when you try to subtract this equation, 3x minus 4y equals minus 0.5, try to subtract it from this, you don't really get x plus y. And when you try to add also, you don't really get anything close to that. So we have to solve for x and solve for y and then add them. That would be one way to solve this problem. So we have simultaneous equations that we are trying to solve. And let's see, what method do we want to use to solve these two equations? So 3x minus 4y equals minus 0.5. So we can try to eliminate y. For instance, if we multiply this equation by 2, let me change this. So let's say we multiply this equation by 2. When we do that, what do we get? We get 8x minus 4y equals 2. So we have minus 4y here, and we have minus 4y here. So we can subtract one equation from the other. So let's say we subtract this one. Let's call this equation 2. We want to subtract equation 2 from this equation. Let's call this equation 3 because we want to call this one equation 1. So let's write this equation 3 minus equation 2. What does that give us? It gives us this 8x minus 4y equals 2. Then now we have minus equation 2 is 3x minus 4y equals minus 0.5. So this subtraction, what does it give us? Well, 8x minus 3x is 5x. So we have 5x here. Minus 4y minus minus 4y. That gives us 0. And then we have 2 minus minus 0.5. That gives us 2 plus 0.5, so 2.5. If 5x equals 2.5, then we can find x. X is 0.5. So we now use this value of x to find y. We can do that by substituting this value of x into any of the equations we got. So let's substitute this into equation 1. So let me write that. Put x equals 0.5 in equation 1. When you do that, you get 4x, which is 4 times 0.5, minus 2y equals 1. 4 times 0.5, that's 2, minus 2y equals 1. So minus 2y equals 1 minus 2, which is minus 1. That gives us y equals 1 over 2, or if you will, 0.5. So we have that x equals 0.5 and y equals 0.5. That means that x plus y is 1. So our answer is C. Question 33. In the diagram, PQRS is a circle. Center O. So the center of the circle is O. And angle RQS equals 40 degrees. So RQS, that's this angle, is 40 degrees. Find angle PRS. So PRS, that's this angle. All right. So one way to proceed is to see that this angle, PRS, this angle is the angle subtended, or is an angle subtended by this chord, PS, at the circumference. And this chord PS also subtends this angle at the circumference. That means that this angle and that angle are equal. They are congruent. They have the same measure. So if we could somehow find this angle, then we could find, if we could find this angle, then we could find this angle. So what other observation can we make? If we observe that PR, line PR is a diameter, then if we see that PQR, which is this angle, is the angle that diameter is subtending at the circumference, then it must be a right angle. So angle PQR, that's this angle, is 90 degrees. This is one of the circle theorems, that the angle subtended by a diameter at the circumference is 90 degrees. So if this angle is 90 degrees and part of it is 40 degrees, then the remaining, which is this one, PQS, must be 50 degrees. So this angle must be 50 degrees because this angle plus this angle is 90 degrees. Now we already said that this angle, PQS, has the same measure as this angle, PRS. So this angle must also be 50 degrees. So our answer is A. Now, this is one way of doing it. We have other ways of thinking about the problem. So let me just clean what we just did and see if we can find another way of solving the problem. All right. So we start by making some observations again, that if this is the center, then this line is a radius. A line from the center to the circumference is a radius. And another line from the center to the circumference is also the radius. So this is also a radius. That means that this and that have the same measure. That makes this an isosceles triangle. So if this is 40 degrees, this must also be 40 degrees. So that's a first step. Another observation we can make is if we see that, again, the angle subtended by a diameter, this is a diameter. So the angle subtended by a diameter at the circumference, that is 90 degrees, just like we found before. Then we see that this angle must be 90 degrees. Now, if this angle is 90 degrees and it can be divided into two so that one of them is 40, then what is the other one? This is 90 degrees. One of them, one part of it divided into two, one part is 40 degrees. So the other part must be 50 degrees. So that's another way of doing it. And there are other ways of doing it. So you can try to find other ways of finding that indeed angle PRS is 50 degrees. Question 34. In a class, there are 20 boys and 15 girls. Two are selected at random, one after the other, without replacement from the class. What is the probability that they are both boys or both girls? So we have a certain number of boys, 20 boys, right? 20B for 20 boys and 15 girls, 15G. And we are selecting two of them at random without replacement. Without replacement means that when you select somebody, you don't put him back in the class. So let's draw some dots for the boys and girls in the class. When you pick out somebody from the class, that's it. You don't bring the person back before you select again. So what is the probability that if we select two, we get boy, boy, or girl, girl? So that's what we're trying to find. We want it to be that the first person we select is a boy and the second is a boy, or the first we select is a girl and the second is also a girl. Well, one way to do this is to say that let's first see the probability that the first person we select is a boy. Because there are 20 boys in the class and there's a total of 35 people in the class, the 20 plus the 15 gives us that. So there are 35 people or 35 students in the class. So if 20 of them are boys, the probability that the first person you select is a boy is 20 over 35. And then, having done that, the probability that if you select again, you'll get another boy is now 19 over 34. 19 over 34 because after selecting the first boy, now you're left with 19 boys. And you're also left with 34 people. After selecting one person, bringing him out, you no longer have 35 people in the class. You now have 34. And then of those 34, if the first person you selected was a boy, then you no longer have 20 boys in the class, but 19. So this is the probability that we will select a boy first and then select a boy second. Now let's look at the probability that we'll select a girl first and then a girl second. Starting the whole experiment all over again, there are 15 girls. So the probability that if we start afresh, we'll select a girl first is 15 over 35. Now, having selected a girl first, if we go ahead and do a second selection, the probability that that person will be a girl is now 14 over 34. Again, after selecting the first person, you no longer have 35 people. You have 34 people in the class. And out of that 34, 14 are girls. Now, we are being asked the probability that we get boy, boy, or girl, girl. And here we can add the two probabilities because these two events are mutually exclusive. If you have boy, boy, you cannot have girl, girl. And if you have girl, girl, you cannot have boy, boy. So there's no intersection between them. So if you want to find the probability of the union, that's what the OR means. The union of these two events, we just add the two probabilities. So how do we calculate this number? 20 over 35 times 19 over 34 plus 15 over 35 times 14 over 34. We can try to cancel. 5 cancels 20, gives 4. 5 cancels 35, that gives 7. 5 cancels 15, 3 cancels 35, 7. And then we can try to cancel further. Let's say we cancel 4. 2 cancels 4, 2. It cancels this, 17. And then 2 cancels that. Let's cancel this one. It cancels 7 and also 17. Yes, we could have used the 7 to cancel, but because we are adding two fractions and we have 7 here and 17, it's nice to have 7 here and 17 here as well. So now let's see what we get. We now have this 2 times 19, which is 38, over 7 times 17. What is 7 times 17? 7 is 49. We have a 4, so 119, 119. And then we have another 7 times 17, also 119. And then we have 3 times 7, which is 21. So we have 38 over 119 plus 21 over 119. We add the 38 to the 38 to the 21. We get 59 over 119. So that gives our answer as A. Question 35. The height of an equilateral triangle is square root of 3 centimeters. Find the perimeter of the triangle. So we have a triangle. It's an equilateral triangle. That means that all the 3 sides are equal. And then the height, that's the perpendicular height of the triangle, is square root of 3 centimeters. And we are being asked to find the perimeter. That means that we have to find this length. Of course, because it's equilateral, all the lengths are the same. So this plus that plus that. We want to find the length around that. So let's call the length of this side x. The length of this side is x. Of course, that means that the length of this side is x and the length of this side is also x. But now this perpendicular height divides this side, which is x, into 2 parts. So we have this part on the left and this part on the right. That means that each of them has a length of half x. So we have half x here and half x on the side. So we can now look at this triangle. It's a right angle triangle. So we have on one side the square root of 3, on the other side half x, and on the third side we have x. Let me just draw that again. So here is x, here is square root of 3, and here is half x. So we can apply Pythagoras theorem, which says that the length of the hypotenuse, this side, if we square it, we get x squared. This is equal to the square of this, which is square root of 3 squared, plus the square of this, which is half x squared. So we try to simplify this. Let's see. We have x squared. Square root of 3 squared is just 3. And then half x squared is half x times half x. That becomes 1/4 x squared. So we have x squared here and 1/4 x squared here. So we subtract 1/4 x squared from both sides. What do we get when we do that? We get 3/4 of x squared is equal to 3. So we can multiply both sides by the reciprocal of 3/4. When we do that, we get x squared equals 3 times 4/3, which is equal to 4. So if you have x squared is equal to 4, then x is equal to 2. So the length of this side is 2, the length of this side is 2, and the length of this side is 2. So if you're looking for the perimeter, which is the distance around the whole thing, is 2 plus 2 plus 2, which is 6 centimeters. So the next question is question 36. When the sum of 84 and a certain number is divided by 3, the result is 5. 5 times the number. Find the number. So there's a certain number. Let's call it n. It says the sum of 84 and a certain number. So n plus 84. When you divide it by 3, the result is 5 times the number. So when the sum of 84, so we have our 84 here, and a certain number, we are calling our number n, it's saying the sum, so we add them. The sum of 84 and a certain number, when it's divided by 3, so we have our 3 here, the result equals 5 times the number, so 5n. All right, so how do we solve this? We can multiply both sides by 3 to get rid of the fractions. So when you do that, you get n plus 84 is equal to 5n times 3, which is 15n. We can now subtract n from both sides. We get 84 is equal to 14n. We now divide both sides by 14. And what do we get? Divide this by 14. Divide this by 14. 84 over 14 is 6. So we have 6 equals n, or n equals 6. So our answer is A. Question 37. In the diagram, PQ is a tangent to the circle at Q. Sorry, PR is a tangent to the circle at Q. So this line is a tangent to the circle at Q. TQS is 49 degrees, that's this angle. And TSQ is 52, that's this angle. Find SQR. SQR is this SQR. So this angle is what we're trying to find. Now, what do we do? Well, this is an example of an application of the alternate segment theorem that says that if you have a tangent and a chord like this, then the angle that the chord makes with the tangent is equal to the angle that the chord makes in the other segment. So this angle and this angle are equal according to the alternate segment theorem. So by that theorem, these two angles are equal. Now this is helpful because we have a triangle in which we know this angle 52 degrees, this angle 49 degrees, and this is what we are trying to find. If we find this, because they are equal, we are going to conclude that it's equal to that. So let's call this x. So we have x plus 52 degrees plus 49 degrees equals 180 degrees. So we add these two quantities. What do we get? 52 plus 49 is 101, and that's equal to 180. So x is 180 minus 101, that's 79. So if x is 79, then this angle is also 79 degrees. Question 38. The fifth term of a geometric progression is 16 times the third term. Find the positive value of the common ratio. So in a geometric progression, let's say you have your terms like that going, and we are told that the fifth term, let's call this the fifth term. Normally we use the notation U5, so UN to represent the nth term. So this fifth term, that'll mean that this is the third term. So you have your fifth term, your fourth term, your third term, your second term, all the way, of course, up to your first term. And then this one also continues. Now we are told that this fifth term is equal to 16 times the third term. So we can write that U5 equals 16 times U3. Well, what do we know about geometric progressions? We know that in a geometric progression, the way you move from one term to another is by multiplying by a number called the common ratio. So you multiply by r to get that. You multiply by r again. If you want to now move here, you multiply by r again. So times r times r times r. If you want to move to this place, you multiply by r again. So you keep multiplying by r. That means that to move from the third term, you multiply by r to get the fourth term, and you multiply by r again to get the fifth term. So let me write that. When you take the third term, you multiply by r the first time, that will give you the fourth term. If you multiply by r again, that'll give you the fifth term. So we have this. U3 times r equals U5. Now r times r is r squared. So we have U3 times r squared equals U5. So we have two expressions for U5. This is the first one. U5 equals 16 times U3. And we have this one too. U5, let me write the other way. U5 equals U3 times r squared. So comparing these two, it means that 16 times U3, let me write that here. 16 times U3 equals U3 times r squared. So here we can divide both sides by U3. That gives us 16 equals r squared. Now, if 16 equals r squared, then r must be equal to 4. It can be plus or minus 4, but we've been asked to find the positive value. So we only care about plus 4. So r must be 4. That gives our answer as B. Yes, there are other ways to think about this. In general, the nth term of a geometric progression is written as ar to the power n minus 1, where a is the first term and r is the common ratio. That means that u3 is a times r to the power 3 minus 1, which is equal to ar squared. And then u5 equals ar to the power 5 minus 1, which is equal to ar to the power 4. So u3 equals that, u5 equals that. So if you're now told that the fifth term is 16 times the third term, what does it mean? It means that this ar to the power 4, let's write that, ar to the power 4 equals 16 times this AR. Let me write AR squared like this. So you're trying to solve this equation. And how do you do that? One way is to divide through. We have A on the left and A on the right, so we can divide through by A. We also have R squared on the left, and we have R to the fourth on the right, so we can divide both sides by R squared. If you do that, this R squared goes away, and this R to the fourth now changes to R squared. So you now have to solve the equation R squared equals 16. And if R squared equals 16, then R must be 4. Again, it can be plus or minus 4, but we only want the positive value of R. Question 39. Find the distance between P 6 minus 5 and Q minus 2, 1. So here we just use the distance formula. If the distance is D, then according to the distance formula, we have x, call it x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula. We can call either of the points 1 or 2. So let's call this 1 and let's call this 2. So then using the formula, we have, what is x2? x2 is minus 2, and then x1 is 6. We square that. What is y2? y2 is 1 minus 5. So this, then we come and write again. Minus 2 minus 6 is minus 8. So we square that. And then 1 minus 5, that becomes 1 plus 5, that's 6. So we have 6 squared. And this is equal to 8 squared is, or minus 8 squared is 64. 6 squared is 36. So we have the square root of 64 plus 36 is 100. So the square root of 100 is 10. So that gives our answer as A. Question 40. In an examination, 32 candidates passed economics, while 36 passed government. If 18 candidates passed both subjects and 10 failed both subjects, how many candidates sat for the examination? All right, so we can draw Venn diagrams for this. We have economics. Let's call that E. 32 candidates. So if this is the set of people who passed economics, there are 32 people in this set. We also have government. So assuming there's some intersection, 36 students passed government. All right. And then we also have that 18 passed both subjects. So this is the intersection. Those who passed both economics and government, 18 candidates or students. All right. We also told that 10 failed. So somewhere outside those who passed economics and those who passed government, we have some 10 candidates who failed both subjects. And the question is now, how many candidates sat for the examination? So we want to know the total number of candidates that sat for the examination. Well, we can draw this around so that we know that this is the whole universe of things that we are dealing with. But really what we are looking for is this. We can think of it as this. Or we can think of it as, the people in this area. So that's this. Plus the people in this area. Let me shade in a different color. And then the people in this area. And then the people in this area also. So everything outside here. This is those who failed both subjects. So we have, if you like, 4 regions to think about. The first is this, those who are here. That represents all those who are in this area. Then the second is those in the intersection. And the third is those in G only, and then those who are outside. So one way to do this is to say that, well, the people here and the people in the intersection, they are the people in this full circle. They are the people in the circle E. And there are 32 people there. All right. Now we need to come and find the people in this area. And the way to do that is to say that, well, this full circle for geography has 36 candidates, and 18 of them are in the intersection, which is part of it. So that means that this region must have 18 candidates. So we add the 18 here. And then we have the people who are outside. We are told that that's the people who failed both subjects. We are told that there are 10 of them. So this is the sum we are looking for. 32 plus 18 plus 10. 32 plus 18 is 50 plus 10 is 60. So that gives our total as 60, which is A. That brings us to the end of this video where we've solved the questions 31 to 40 in the 2026 WASSCE Core Maths Paper 1. Again, the full set of questions and solutions may be found at preppyonline.org.